Hello and welcome to our fifth lesson, really our fourth lesson. We had a work day in there, but we are going to look at how scatter plots are created, and then tomorrow we'll look at how to interpret them. So be prepared to better understand what a scatter plot is and how it might be used in today's lesson and tomorrow's lesson. So to start with, let's talk about what a graph might look like. We have two types of graphs we generally work with. Other than the form that we see, we have a continuous graph, which is a connected curve. Doesn't have to be curved, by the way. It could be a straight line, but it has to be a solid line. It's connected. All the points are connected. Versus a discrete graph where there are just points being plotted. And what we're going to do, just as a heads up, we're going to take data points, put them on a graph, and then try to make a connected curve that can predict what the values might be. So be prepared for that. The graph that we create by plotting points is called a scatter plot. Scatter is a good word there. It implies that the points are not necessarily all what we call collinear or on the same line. If it shows the relationship between two quantitative variables, and the quantitative variables need to be numbers, and we are looking for a connection, a relationship. Okay, so looking at graphing X, basically one of the ways you're going to get the information is typically in a table or a T-chart where you're going to plot the X and the Y and plot all the points. So when we look at the X-axis, this is a convention we take. The bottom of our graph, the horizontal line, is going to be the independent variable, or the X-axis. And then the Y, the vertical, is going to be the dependent. So the variable Y will depend on what the value is for X. A typical easy kind of thing to think of there is, if you're getting paid $12 an hour, you could say P equals 12H. H would be my independent variable. I figure out how many hours I'm going to work. My pay would depend on how many hours. Obviously, it also depends on this 12, but that's a different term. That's basically our slope. So independent variables happen. Dependent variables are determined because of that independent variable. And the correlation, basically how closely or how accurately we can predict how the independent variable affects the dependent variable, the term we give is correlation. So if we had a positive correlation, we wouldn't necessarily see a perfect line, but if you look at a trend here, it looks like as X increases, Y increases. So I'll just write that. X up becomes a Y going up also. You might be able to predict then the negative. If you have a bunch of points that are looking like there is a pattern, we would say that this is a negative correlation and it's a negative slope. So as X goes up, we always talk about the independent variable going up, then the Y would go down. And then if we look at the data and it's not real obvious, for instance, if you look at something like this that really looks like a scatter, it's hard to predict if there's a pattern at all. We would just say there's no correlation. So they're independent and independent, you could say. So we're going to look at Desmos activity for the classwork. Go to Google Classroom. You'll be asked to identify what the independent and dependent variables are, as well as what kind of trend you're seeing. Is the Y increasing as X increases? Is the Y decreasing as X increases? We always do X increasing, or is there really no connection? And what you'll see is these kind of graphs. And I think it's fairly obvious if there's a pattern, if it is positive, negative, or if there isn't one. So get to work on this, and then you can look at the homework, and we'll see you in class.